Okay, today we're going to do a slightly more difficult integration by parts problem, but we're still going to be using the same general formula. And that formula for integration by parts is, once again, the integral of u times the derivative of v equals u times v minus v du. And so basically we input values for u and v and solve accordingly. So if we were given the problem, the integral of x squared sine 4x dx, how would we solve this problem? Well, of course, we want to start assigning values. And so we start by assigning values of u and dv. And we generally, the convention is to give the more difficult term, meaning the difficulty that it takes to take that term's derivative, we give that more difficult term the value of dv. So of course, taking the derivative of sine 4x is a lot harder than taking the derivative of x squared, since you can just use the power rule for x squared, and for sine 4x you need to use the chain rule. So we want to give the value of the derivative of v, dv, equals sine 4x. Keep in mind that in this formula, even though we've just defined our term for dv, we also need to define v. If we don't know v, we can't do this formula. So basically, that means that we're going to have to take, forgot to put my parentheses here, basically that means that we're going to have to take the antiderivative of dv, or sine 4x. And how do we do that? Well, with this we can kind of use a little trick with the chain rule and kind of do a process of elimination. So we want the antiderivative of dv, meaning that we want a term that when we take the derivative of it is going to give us sine 4x. So we start asking ourselves, what's the derivative of sine x? Let's call this an outside function that we're going to name h prime. Let's break this function down into its component parts of sine x and 4x. All right, so and then we're going to take the derivatives of both those terms. So if we have sine x, we know the derivative to be, of course, cosine x. If we have 4x, we know the derivative to be, of course, just 4. So that gives us two clues as to what we're going to take the derivative of in order to arrive at sine 4x. So basically, we know that we're going to have to take the derivative of cosine x at some point. So using our chain rule, which we know to be h prime of g of x times g prime of x, where h of x is the outside function and g of x is the inside function, we can now ascribe cosine x, the value of h of x, and 4x, the value of g prime of x, or I'm sorry, g of x. So now using our chain rule, let's take first the derivative of cosine x. Cosine x is, of course, minus sine x. And now, and this is also equal to h of x, remember. And now we take, again, the derivative of 4x, which we know to just be 4. Sorry, those shouldn't be equal signs. So now, and once again, this equals g of x. So now we can input these values into our chain rule in order to gain more insight as to how we're going to take the antiderivative of sine 4x. So let's say we have, I don't know, cosine 4x. And so let's just experiment. What happens when we take the derivative of cosine 4x using the chain rule? Well, we would get if cosine is equal to h of x, we would get minus sine, and remember g of x is equal to 4x, minus sine 4x times g prime of x, which is just going to be 4. So now we're getting a lot closer to our value of sine 4x, but we're not quite there yet. So how can we manipulate the function of cosine 4x in order to get the desired value of sine 4x when we get the derivative, when we take the derivative? Well, we can tack on a 1/4 here, right? We can tack on a 1/4. And that would cause this 4 to become 4 over 4, right? Which would just equal 1. So that's the way that we would get rid of this 4. But remember, we have a minus sign here, and we don't want that either. So if we just tack on a minus 1/4 to the cosine 4x, and we take the derivative of that, let's see what we get. So we have minus 1/4 cosine 4x. And then when we add this constant in, we get this to cancel out and this to cancel out, and we're left with sine 4x. So we do in fact now have the antiderivative of sine 4x, which is just minus 1/4 cosine 4x, which is also now equal to v. So now we have our value for v, and we can erase all of this. Alright, now that we have all that erased, let's say that u, since we already gave the value of dv to sine 4x, u must be x squared. So u equals x squared, and of course the derivative of u, du, is just equal to 2x. Now we can start inputting values into our formula here for integration by parts. So we rewrite it out here. We say that the integral of u dv is equal to x squared minus 1/4 cosine 4x minus the integral of minus 1/4 cosine 4x times 2x. Now keep in mind that we have two negative signs here, and remember this is a constant, this 1/4 is a constant, and this 2 is a constant. So it would be like saying, when we take the constants out of this integral, it would be like saying 1/4 times 2 over 1, which is going to give us 2/4 or 1/2. So we can now rewrite the equation. And remember that the convention is to generally take these constants out and put into the leftmost part of the equation. So we will rewrite this. We'll rewrite this as minus 1/4 x squared cosine 4x plus, because remember the two minus signs change into a plus sign, plus 1/2 times the integral of cosine 4x times x. And so we're still not done with this problem because we now have cosine 4x times x to worry about, the integral of it. So unfortunately we're still not done with this integration problem because we're left with this term out here, which is the integration of cosine 4x times x dx. So we're going to have to once again use our formula for integration by parts, and we're now going to label our values all over again. And then at the end we're going to add this entire term and multiply this 1/2 all the way out, and we'll see how it works out in the end. So our dv is of course going to be the harder term to take the derivative of, so we're going to give the value of dv to cosine 4x. So cosine 4x is going to be our value of dv. And as we discovered earlier, the integral of cosine 4x, or the antiderivative of cosine 4x, is just going to be 1/4 sine 4x. And you can use the chain rule to take the derivative of that and see that you're going to arrive at cosine 4x. So we give the value of 1/4 sine 4x. And we just give the simple x the value of u. And of course the derivative of u is just going to be 1. So now we input our terms once again into this formula, and we are going to see, let me just make a little bit of room here. we're going to get x times 1/4 sine 4x minus the integral of 1/4 sine 4x times 1. And so the 1/4 comes out, and we can just rewrite it as 1/4, and we're just left with the integral of sine 4x. So we've already taken the integral of sine 4x when we discovered it to be minus 1/4 cosine x. So we know the antiderivative of sine 4x dx, which is the only term needing to be integrated right now, is minus 1/4 cosine 4x. So now we have this entire term that needs to be multiplied out. This term here needs to be multiplied out. And so we take this minus 1/4 and times it again by minus 1/4, and that gives us positive 1/16 cosine 4x. And then we rewrite this entire rest of the equation as 1/4 x sine 4x plus 1/16 cosine 4x. And remember that this entire equation here, this entire term also has this portion of the answer of the integration of x squared sine 4x. So we tack on minus 1/4 x squared cosine 4x plus 1/2 multiplied by this entire term here. So let's do the multiplication out. We rewrite the beginning of the term here in black, 1/4 x squared cosine 4x plus 1/2 times 1/4 is going to give us 1/8. So 1/8 x sine 4x, and then the 1/2 times 1/16 is going to give us plus 1/32 cosine 4x. And that is equal to the final answer. So it's equal to the integral of x squared sine 4x dx. And I made a common mistake here. I forgot to add right here the term of plus c, which is any constant. So there you have it. This is the final answer for this problem. And I know it's pretty lengthy, but as long as you keep to this formula of integration by parts until you remove all of the necessary integrals, then you will arrive at the correct answer. Thanks for watching. Please subscribe, rate, and comment.